Okay. Right, so what's the first derivative question there? Did you find the page it's on? What page is it on? There's a table of contents at the front. What do you mean?
Oh, page 19.
Page 19, okay. You have it there?
Yeah.
Great. Okay. So let's start then. A curve, what is it? Y equals, thank you, x squared plus 1 over x minus 1. And I want the derivative at the point 3, 5. Whoops. The heck is up with my keyboard? Oh. Now, what rule do I need for this? What differentiation rule do I need? See, we have different rules. The three main ones are product, quotient, and chain. Do you know which rule you need here? You know? Oh, names are important. Product, quotient, or chain. You've got a 1 in 3 chance of getting the right name. Oh, Abdullah, do you mind getting that? Do you know which one? No ideas? That's okay. So this one here, we need what's called the quotient rule. The quotient rule is the one for dividing. Okay, so let me explain how it works. This is what you do. Abdullah, it's the quotient rule. Quotient. So what you do, it's the now, the way I like to do this is, in the book you can match it up with like letters like U and V and all this type of stuff, but I would just prefer to remember it like as words. So in words it's the bottom squared, okay, the bottom times the derivative of the top. What's the derivative of x squared plus 1? 2x, yeah. Minus the top times the derivative of the bottom. What's the derivative of the bottom here? Derivative of x squared minus 1. It's 1, isn't it? Yeah. And then finally, we have to put in x is 3. So let me see. That would be 2 times 6 minus 10 times 1 all over 2 squared, which is 4. So that's 12 minus 10 over 4. That's 2 over 4, which is a half. Is the answer. Now, I'll let you write this down, but what I just want to do here is show you how to do this on the calculator as well. So, also, in word form, it was like I did this. The bottom squared. The bottom times derivative of the top minus the top times derivative of the bottom. That was kind of the idea here. Is this okay? Are you sure? Are you sure? You're sure? Yeah. Let me show you how you can do this on your calculator to check the answer in the exam. Because your the Casio can do this one. Remind me later. Okay. Where's my calculator? Come on. Since we're looking at names, quotient rule is for dividing. Which one is for multiplying? Product rule, yeah. And when do you use chain rule? It's the type of combining. Yeah. Calculator's not quite working right now. Do you notice also in the question they gave you the x and the y? They said 3, 5. But in fact, you did not need the 5 here to do this question, because we only have to substitute in the x. So here we go. Right, so to do this on your calculator, you type in this, shift derivative, and it's when x is 3, And here we can put in the function. So it's alpha x squared plus 1 over x minus 1. Yeah? I want the derivative of this when x is 3. So hopefully I get a half. Yes. So in the exam, I know I got full marks. No problems. Watch. Shift this button. Put x is 3. And then type the question in here. Fraction. No, not double fraction. Alpha x squared plus 1. Plus 1. And then alpha x minus 1. So, oh, I don't think this one has it. No. In fact, who has this calculator? Can your graphing calculator do this?
I'm sure it can, but I just don't know.
Yeah, but you think it probably could do this here. And Abdullah, what calculator do you have? Is it this one or the grey or the black one? No, okay. 85. No, this is the superior one. Okay, next one. Yep. So, let's see what we got for the next one. Aha, a little different now. So we have ft equals t minus log t plus 1 over t plus 1, and we want to calculate the derivative at 2. Okay. Right. There's no difference here. They just replace the letters. Instead of having x, they have t, and instead of having y, they have f. Right, what's the derivative of t? Who knows that? It's like saying what's the derivative of x? It's 1, yeah. And what's the derivative of log t? Do you know this one? This is a language thing. Whenever I say log, I always mean ln. Yeah. This one here is not 0? 1 over t. Yeah. It's the reason is it depends on your education background. So if you're a maths background, whenever you say log, you mean ln. If you have a chemistry background, whenever you say log, you mean base 10. And if you have a computer background, whenever you say log, you mean base 2. So it's education background. Okay, so what do we do with this one if we want the derivative? You might think you need the quotient rule again because it's a fraction. But there's a little trick here. Who knows the little trick? You can change this into something else first. You can change this into t minus 1, yeah. And now we can differentiate. So we bring the power down. And then what power do we get now when we reduce it by 1? Minus 2. And derivative of 1 is 0. And we need the t to be 2. So this will be 1 minus a half minus 2 to the minus 2. Which will be, let me see, that will be a half minus a quarter, which is a quarter, I hope. Let's check on the calculator to see if we've got this right. No, I'm going to check the whole thing. What I'm going to do is put in the whole thing. Shift derivative when the variable is 2, t minus log t plus 1 over t plus 1. I should get a quarter. I did. Okay, so I know that this one's right then. Yeah. Okay, write that down if you need to. We'll have a look at another one now and see what we have next. Yes, okay. We are getting a bit different now. Can I scroll down? Yeah, so, do you mind if I put this around that? A curve has equation y equals 3x squared plus ax plus b, and its stationary point is 2, 1. Find a and b. Okay. What does stationary point mean? So we have a quadratic. What's the meaning of stationary point? Which point is it on the graph? Do you know? Which one do you think it is? There's not many points to choose from.
The point which goes after y?
This one here.
Yeah.
No.
No.
Good try.
0, 2.
That one, yes, is when x is 0. That would be called an intercept. Yeah. What about stationary? Any other ideas? Somebody must make a guess. Another guess. No?
It's just the point where the graph the curve.
No? No? Abdullah? You're looking quiet. No? What about this point? That's the stationary point. It's the lowest point, the turning point.
Oh,
Yeah. Same thing, it's the same thing, correct. Stationary point is a synonym for turning point. Do you know other synonyms for stationary point? Turning point? What else could you call this point? You could perhaps call it the minimum. Yes, yeah. Minimum. Anything else? There's one more and it begins with a V. Vertex, correct. Yes, very good. Okay, so how do you find the stationary point? How do you find this turning point? Does anybody know? How do we get this? There's actually two ways to get it. I wonder if you know. Nope. Long forgotten? Yes, absolutely.
We differentiate.
Yeah. You differentiate. So here the derivative is 6x plus a. Yeah.
We put x.
Yeah.
We put 2 instead of x.
Yes, and then
And dy divided by dx is the same as what?
oh, it was going well, but not quite at the end. Yeah, you nearly had it. The derivative must equal 0 for the stationary point. It must equal 0 because the derivative represents the slope, and at the stationary point the slope is 0. So therefore 6x must equal minus a, and so x equals minus a over 6. But you're told that x should be 2, because you're told the answer here. So that means 2 should equal minus a over 6, and so a has to equal minus 12. Okay, well that's good, we have the a, but what could I do to get the b? So let me just zoom out a little bit. We now know that y should equal 3x squared minus 12x plus b, but I need to get the b still. What could we do to get the b, do you think? Any ideas?
We'll take sin y.
Say again?
We'll take sin y in the equation.
Sin y?
No, x and y.
Oh yeah.
Values of x
Values of x and y, yeah, and then what do we do with the values of x and y?
We get
Sorry, I missed, what did you say? What do we do?
We would get
Oh, put them in, yeah, that's it. What's the verb to put them in?
Substitute.
Substitute, yeah. So what we do is we substitute this in here. We know the x and we know the y, and we can get the b then. So y is 1, that should equal 3 times 2 squared minus 12 times 2 plus b. This should give us the b, because we'll get 1 equals 3, no, not 3, sorry, 3 times 4, 12. 1 equals 12 minus 24 plus b. So what's that? b equals 13. b equals 13. And we have here a equals minus 12. That's harder, isn't it? Yeah, that's kind of a hard one. Now we'll get a harder one again. Well, actually, the next one's not that bad. Okay, can I do the next one? Yeah. So the next one here you can see is a little bit of a story one. It says a kiln. Does anyone actually know what a kiln is? It's like an oven. Is heated, a cooker, is heated, and when it reaches a certain temperature, it is switched off and allowed to cool. The temperature is given by the formula shown below. So theta represents the temperature. So you're told that the temperature equals 150 EKT plus 25. So let's just write that down. The temperature equals 150 EKT plus 25. Okay, good. And show that, or state the temperature of the kiln when it is switched off. Oh, okay. So, in other words, they want to know the temperature when the oven is switched off. In other words, they want to know the temperature at the beginning. So remember, theta here is temperature. How can we get the temperature at the beginning? What's the time for the beginning? What do we put in for t? 0, yeah. So if we use t as 0, we get theta equals 150 E0 plus 25. And that will come out, 150 there, and that will come out as 175 Celsius.
It's actually 1050.
Oh, is it 1050? Thank you. So I need an extra 0 here. That's a hot oven. Right, theta will equal 15. Oh, sorry, 1050, not 1500, sorry. Thank you. That's still a hot oven. 1050, okay. So then theta will equal 1050 E0 plus 25, which is 1075 Celsius. Is that part okay? Yeah? Part 2. The temperature after 2 hours is 697. Find the value of K. So after 2 hours, so what's the T? 2. And what's the theta? 697 Celsius. Okay. So if I sub this in, I get 697 should equal 1050 E minus 2K, because the T is 2, plus 25. Now, how can I solve this for k? What should I do? What should be my first step? Try to rearrange it, but what should I bring where? Before ln, yeah. It's a little too early for ln, something before that. I'm going to bring the 25 to the left first. So, 697 minus 25 is 1050 e minus 2k. So that is 672 equals 1050 e minus 2k. Now what should I do next? Say again? Yep. So what should be my next step? What should I do next? I should bring something to the left. What should I bring to the left? The 1050. So what I'll do is I'll divide it. Okay. Can you tell me if this fraction simplifies? 672 divided by 1050? I think you can at least divide it by 2. What does it simplify down to? Oh great, 16 over 25 equals e minus 2k. Abdullah, what should I do next? Yes. So, now I'll put ln here. Now why do I put ln? What happens by using ln?
Take 2k down.
Yeah, you can take 2k down. So this is gone. Like that. Yes, good. And next, Abdullah, do you know?
Take by the calculator. Take that one off there and do that one.
No, actually, not this time, because actually I didn't say this. But in the question, if you see there, it says give your answer. Doesn't it say give your answer as log a over b? So they don't actually want a decimal. But what about log e? What's log e here? If you don't know, you can type it in, ln e. But does anyone know ln e, what it is? You go on, you're about to say it, but you're not. Yes, that's it, Jeff. ln e is 1. So we get log 16 over 25 equals minus 2k. So we get k equals log 16 over 25 over minus 2. But there's a problem. They said they want the answer like this. They want the answer as ln a over b. And I don't have this. I have ln a over b over c. And they don't want the answer like this. So there's a little problem we have to fix. I need to do something about this minus 2, because I don't want the minus 2 there. So if I write it like this, it might give you a clue. If I write it as minus 1 over 2 log 16 over 25. Any ideas on how I can get that minus a half out of the way? Any ideas? Some log rule will be helpful here.
Make it to the power.
That's it. What I can do is I can take this up to the power. I'm actually doing the reverse of the rule earlier where I took the power down. I'm literally doing the reverse. So, I wonder actually, if you were to type in just the 16 over 25 minus a half, your calculator might be able to give you the answer here. No, don't type the ln, we need to keep the ln. Will your calculator say 5 over 4? It said 5 over 4? Did it give it as a fraction or a decimal for you? Fraction. You got 5 over 4? Yeah, that's good, okay. How many marks is for that part now? What? Only 3? Are you sure? Oh, japers. Alright. Okay, and now the next one for 3 marks is the derivative. Okay, so let's just write down what we have so far. We have theta equals 1050 e minus, it was minus k, wasn't it? Minus log 5 over 4 t plus 25. Okay, now we want to get the derivative. Does anybody know what the rule is when we want a derivative of something like this? When we have where's my pen? Can't see it. Here it is. EKT, or whatever, EAT, whatever. I'm sorry, I mean to say EAX. Do you know what the rule is if you have EAX, like E with a power? What do you do for its derivative? Does anyone know? Try again, not quite that, not the X. The A comes down, yeah. I think that's in the formula book. So this becomes 1050 times minus log 5 over 4 E minus log 5 over 4 t. And the 25, its derivative? 0. And what did they say the t is for this one? 14, like this, yeah? Okay, so we need to type in on our calculator 1050 brackets minus log 5 over 4 bracket e power bracket minus log 5 over 4 close bracket times 14. Right, so we'll need to type that in if you don't mind. I can type it in too, actually. 1050 minus log 5 over 4 e power minus bracket log 5 over 4 close times 14. Right, let's see what I get. I get minus 10. Does it say anything about decimal points? No. So minus 10.3 degrees per, are we using hours or minutes? I forget. Hours, isn't it? Yeah. Per hour. Okay, is there another part? Explain why. What background? Explain why we're using this formula. The temperature of the kiln will never reach 20. That's a little bit tricky. I wonder now, what part is that? That's the last part, part 4. Explain why it's impossible for the temperature to become, well, I've got to write in the K, 20. Can anybody actually see that? Why is it impossible for the temperature to become 20? It's not very clear, but I wonder if anyone can see. The question's basically saying, why can I say that theta can never be 20? Because. Can anybody see why? In this formula, we can never get 20. I'll give you a little clue. If I have y equals x squared plus 5, I can say y must always be bigger than 5. Now, why can I say that? Why can y never be smaller than 5? Why does y have to be bigger than 5 always in this formula? No, we don't see? You don't see? Okay, I'll help you. X squared, that must always be positive. True or false? True. Why? It's a square. Squares can only be positive, okay? If you have a positive number and you add it to 5, can you ever make it smaller than 5? No, why not? Well, because when you add a positive number to something, you can only make it bigger. So in fact, what is the smallest that this could ever be? It could only ever be at least 0, because it can never be negative. Never be negative. So it means that this can be at least 5, because we can never remove anything from the 5. Can you see that? So if we go back here, I don't know if you know this, but exponential functions are like square functions. They have to be positive. They can never be negative. So the reason theta must never be 20 is because theta must be bigger than or equal to 25. In fact, I really should say theta should be bigger than 25. Because when you have a positive and you add 25 to it, the result is at least 25 or more. A positive added to 25 cannot make it smaller than 25. So it has to be at least 25, which means it cannot be 20. Tricky, but I wonder, does it make sense? You don't look happy. Are you sure? Abdullah? You don't look happy?
No, so.
Yeah, no, I understand this feeling. Okay, we'll continue then. The next one is another long question. It's kind of like the section B question. You might have seen this before in the semester 1 exam, I'm not sure, where they're giving you a shape. You have to use some calculus on it. Yeah, okay. Can I scroll down? Yeah. Right, so, first things first. Figure 2 shows a cylinder with radius r and height h. Its total surface area is 3 pi over 2 meters squared. Find an expression for h in terms of r. Okay. Right. They have given me the surface area. The surface area is the area, if you imagine that the cylinder was wrapped in paper, it's the area of the paper that's wrapping around it. So, I don't know if you know this because the formula is not in the formula book, and the last time you would have seen the formula for surface area was back in middle school, a long time ago. So, does anybody know the surface area formula for a cylinder? Long time ago. It's two circles plus a rectangle, so it'll be 2 pi r squared plus 2 pi r h. How long ago since you saw that now? 5 years? 3 years? Huh? You saw it recently? Semester 1 you saw it, okay. Now, we know the surface area. What did it tell us it is? It's 3 pi over 2. Now, if you were to read the question, they want find an expression for h in terms of r. So we need to rearrange this. What are we trying to get by itself? What are we trying to make the subject? What are we trying to isolate here? What do you think? Are we trying to get the or are we trying to get the h by itself? It's the h, isn't it? Because that's find an expression for h. So I think I should bring the 2 pi r squared to the left. And what should I do next? If I'm trying to get the h. Yeah, I should divide by 2 pi. So I have 3 pi over 2 times 2 pi r minus 2 pi r squared over 2 pi r. That's good because I can cancel. What can I cancel here in the first one? Pi with pi. So I'm left with 3 over 4r. And what can I cancel here? Quite a lot. 2's and pi's and an r and an r. So I'm left with r. That's what the h is. H equals that. Okay, that's part 1 done. Part 2 find the formula for the volume. Right. Does anybody remember the formula for the volume of a cylinder? No? Yes? Impossible? Pi? No? Not coming to anyone? No inspiration? Okay. Pi r squared h for the cylinder. It's unfortunate that they don't put these formulas in the formula book, but they expect you to know it. So you might want to print them out from some web page just to refresh your memory. Okay, we have a formula for h though. It's 3 over 4r minus r. So if I multiply this in, I'll get 3 pi r squared over 4r minus pi r squared times r. So in other words, I'll get 3 pi r over 4, because I can cancel the r's here, and that'll be minus pi r cubed. Is that what they have in the book? What they want you to get? Exactly, yeah? No difference? No difference, good. Next, use the derivative to find the r which makes it a maximum. So how do you make something a maximum by using the derivative? What do you do? We get the derivative, yeah?
This negative?
No, not that one. You're thinking of the next part before that.
We got the volume
Yeah?
and we differentiate again.
No, before differentiate. First differentiate it once, and then what do you do with that? After you differentiate it. You have to make it equal to something. You're thinking of the next step. The step before this. Does anybody know? I'll tell you. So, if you want to make something maximum, what you do is you make its derivative equal to 0. So, say that again. If you want to make something maximum or minimum, you make its derivative equal to 0. So, the derivative here will be 3 pi over 4, because this here is like a constant. And then this derivative will be minus 3 pi r squared. And I said that you make this equal to 0. Is that okay, Abdullah? Yeah, you remember this now or not?
Yes.
Yeah, the 0 part. So you have 3 pi over 4 should equal 3 pi r squared. And what can I cancel here nicely? What cancels on both sides? What do we have on both sides in common? 3. What else? Pi. And then how do I get rid of the square? Square root both sides. So you end up getting r equals 0.5 meters. And finally, Abdullah, I think you know this answer. How can you confirm? How can you check that it's a maximum? You were telling me a minute ago. You said it 2 minutes ago. What do you do? Differentiate again. Okay, so the second derivative here. So what's the derivative of 3 pi over 4? Who knows that?
0.
Yeah, why 0?
Constant.
The constant. And the derivative of minus 3 pi r squared? Minus 6 pi r, yeah. And then what did we say the r is? 0.5. So this becomes minus 3 pi, which is roughly something like minus 10. But we don't care about the exact number. We just care about knowing if it's positive or negative. And since the second derivative is negative, what does that tell us? Do we have a maximum or a minimum? Do we know? is actually opposite of what you think. If you have a negative, it means you have a maximum. And if the second derivative is positive, it means you have a minimum. Oh, sorry, I wrote my mistake. Well, not, I wrote the wrong letter here. It's not V, it's oh wait, hang on. Did I screw this up? I think I screwed this up. No. No, they wanted maximum volume. Yeah, so that's right. Where's my pen gone? No, that is a V. Hello? There we go. Well, computer's getting a bit hot, I think. V. Ah, it's a V there. It was V there a minute ago. Okay, so we have maximum volume using the radius of 0.5. This will give us the cylinder with the biggest volume. Is that tricky? I don't know now how you feel about these types. You look fairly unhappy with these. Yes? Would I be right in thinking next week we'll want to do more of these? Okay. What time are we at now? Yeah, okay. Have we probably, yes, we do have much more to do. You can do as many as you like, nearly. We have another, sorry, we did this one, didn't we? Yeah, and we have this one here we could do, and we have this one with the box we can do. They like these questions in the exam, I'm sorry to tell you. Yeah?
Can we do something about the probability of stuff?
Yeah, we can. Yeah. What's the probability you do in semester 2? Is it the normal? Binomial? Which one do you do? Tree diagram, okay. Tell you what, Abdullah, next week we'll do two calculus and 2 probability questions or something like that. If you want, you can pick them out for next week and let me know which ones you want to see. And you can do the same for calculus, but I have a feeling you want me to do 2 more of these types. Yeah. Okay.